G'day guys, got a 4500 here that is very noisy and not ground balancing properly. And what I discovered after going through this detector, there's a couple of issues, and I've got to find my non-conductive pokey stick so I can point it, but like usual, it's buried on the bench somewhere. I can't see it, but what I'll do, I'll point this out with a pen. Okay, right there's a through plate. You can see that one there. Have a good look at it. It's green. When a through plate has a green tinge to it, it will indicate that it has had moisture get onto it, or some sort of contamination, acids, alkali, or it could even be a contamination in the copper that was on top of the fiberglass board. It could be some sort of contamination in the material they used to plate the through hole, and you got to look out for these. They are extremely hard to spot. These boards have a lot of internal through plating, and also the ones you can see there is lots and lots of through plates. You have to scan the board very carefully, and I would use a phone with a camera, like how I'm using this phone here to make the video, and just sort of, you can do this. It's better than using your eyeballs, and it stands out like the proverbial. So that's our problem there. Now I'll just zoom out a little bit again, and I'll show you. You've got to get something non-conductive. Use a bit of non-conductive plastic. But if you have the board on some rubber, this is rubber or silicon actually, something non-conductive, you could put it on wood, but silicons, rubbers and things like that are much better. So what you can do here, these are the ICs that control the ground balance and earth field cancellation and things like that. Now, I should have used a tripod because I'm going to bend the whole board, but there's a trick to doing, a little trick to finding out where some faulty components are. And yeah, I've got to get the whole board, because the board is like so at the moment. Because of these mylars are pulling the board up, it's going to move the whole board. But basically what you do is you hold the board down. I need 3 hands to do this now because I'm holding the phone, but I'll show you what you do. This will alleviate about probably about 80% of ground balance problems that you come up against. I'm just trying to find something I can lean the phone on. It's not going to work there. Maybe I'll just lean it on the detector. Well, the detector's not picking up the phone, which is good, so you can't see my finger at the moment, but it's over there. I'm pushing down on the microprocessor. Now, I'm holding it down hard. Now, what I do, I get this, push on that IC, push on that IC, push on that IC. Whoops, and there goes the phone sliding down. Murphy's Law. The phone's in a silicon case. What do I expect? Push on that IC. Now I'm pushing on that one. Here's a bit of noise. Oops, we're going for a slide again. So if you're going to get noises from these ICs, it's usually none of the components around here. It's on the other side of the board, so I'm going to flip the board. Let's turn him off. I've noticed this, I always pull the Mylars out. You also notice that it has had the Mylar holder there. Well, it's had a Mylar replaced, I'd say. I don't know which is the original. I'd say those pins are the original. They would have been there, but that's been changed to a non-pin type, just a standard Mylar. This detector has had work done on it. I haven't noticed that too. So should have used a tripod, but if I use a tripod, I can't get in close on things. So always take the Mylars out so you don't destroy them. And around we go. Now, when I first got this in, how about I use a multimeter lead to poke and point? Okay. These capacitors here, these ones, for some reason, they can change values and play up. Now, what I usually do, I don't know if it could be, because the whole thing's covered in white paint, it's very difficult to know if there was a bad connection onto the board or it's a bad termination in the capacitor on the multi-layer stack where it joins, where it solders onto the board. But what I do, I usually get the iron and I go around and touch, give it a bit of resin. The white paint stuffs up the soldering ability of most solders. You really got to put a lot of solder on there. Solder, same thing. And give these a good going over and turn it round, give it another poke. You can operate the detector like this as well, but unless you make up some sort of stand or bracket and have all the Mylars underneath held nicely, you're going to stress out the Mylar strips and end up breaking the copper. So, you know, you really want to give that a test. Like so with the soldering iron first. This would not ground balance in mono mode. It would slightly ground balance in enhanced mode. And by redoing these capacitors here, here we go, one-handed. I've done this a few times so I can get away with it. But that residual, there's a little bit of residual noise from pushing there. It may be a faulty capacitor. I may have to change that capacitor, and there we go, get that in there. I may have to change that capacitor. I've only ever found one of these 2027s, or yeah, you can find there's a JFET version and a bipolar version of these, and if you use all bipolars, it will work. If you use all JFETs, it'll work. Don't intersperse the JFET and bipolar types. There may be component changes that need to be done by doing that too. Trying to think of the other version. I can't think of it off the top of my head. I might have it written down somewhere. But all those chips are the same anyway. Those ones there, the ones up there are all 4053s. Hang on a second. Let's have a look at some of my paperwork here. Because I do write this stuff down. Where am I here? That's definitely not it. Maybe I wrote it in my book. But, I can't, can't see it at the moment. But anyway, turn this, put the coil back on, of course. Don't do this with a mono coil unless it's a cancel coil. Use a double D coil, run it in cancel mode. Otherwise, you're not going to hear the changes over all the other noise coming in. So turn him on. I'll turn up the volume on it too. I have replaced the batteries in my amplifier, as you can tell. In the last video it was making all sorts of horrible noises. But this is running very stable at the moment, and I'm bending the whole board, so if you bend the whole board, just the movements through the board is going to make that crazy sound. I'm trying to jam the phone there again. Ah, dear me. I can come up with a way of doing this. I'll get the multimeter probe and I'll stick it through my bench carpet and jam the phone behind it. There we go. Can't move now. So what you're going to do, I'll move the phone over here a little bit so you can see. Push down hard on the board, and I'll just turn the volume up a bit more on the, there we go, put the speaker next to the phone, and let's push on these. Now I'll get right in close on these. Nothing, but I'm really flexing the board because it's on the silicon. The silicon moves. Still something iffy around there. There is something iffy. Just for the hell of it, I'm just going to go and touch up the legs. This white paint makes life extremely difficult. It's going to heat up each leg, just in case there is a solder issue. I don't think so. It's usually on the other side of the board. The white paint is just making the iron slip. Once you're through it's fine, but just touching it. I could go around and scratch it all off, but not necessary. I want to get onto that little through plate in a minute too. We're going to give that a bit of a suss out, but I'll turn this detector back on. We'll see what's happened. Will we have any change? If I touch the components around it, I think I'm bending the whole board by touching 4053s here. Now, that through plate is on that channel. So what I might do with that through plate, I get a piece of very, very fine wire. What I usually do is I pull a strand out of some multi-strand wire, 0.1 millimeter, 0.12, maybe up to 0.2 of a millimeter. And I'm just hunting around for a very fine wire. There's one there, that'll do the job. I usually grab it with a pair of needle nose tweezers. It's going to be very difficult to do, but we're going to give it a go because it's it bottoms out very, very early on. What I'm going to do with that, hope you can see that, should be able to. Get the soldering iron, hold it there, and hopefully it pulled it out the hole. It's the trouble with very fine wire. Just the surface tension of the solder on the iron pulled it out the hole. So the other trick is you gotta be careful with through plates. You really don't want to scratch them up to access the copper. Because sometimes there isn't any real copper there. There we go. Starting to get a bit of flow on top of that. You can see that it's actually tinned up. Okay, I'm going to see if I can get a bit of thicker wire through it. I probably can't. Oh god, that's miles too big. I've got to go back to the fine stuff again. You want to get the thickest wire that will go in the hole, and I'm just looking around my bench. That's a lot of the wire I've got's too thick and a lot of it's too thin. Okay, can I do it with that? Nope. Okay, there's another way I usually do this too, and it gives a lot more control. I'm just going to find a piece of, just a scrappy bit of wire. I don't know if you can see that, just a scrappy bit of wire like that. Just get a strand. I'll cut it to the right length, so I'll show you how to do this. Okay, I'll fold all that back because it's don't want it in the way. To get some control over it, there we go. I just got a strand, and I can hold on to the wire and get some control. So what I'll do now, I'll put the iron back on that through plate and get lined up. Okay, the wire's actually in there, but what I'm going to do now is try and add some extra solder without it falling out. Now, hold it up vertically. Okay, and do that, push it down. That's probably as far down as I can push that. It's very thin wire. If I had it a bit thicker, I could push it a bit harder, but you've got to be able to get through. There we go. As you can see, I'll zoom in a bit. It's pretty hard to see. It's all gunked up, but I'll just put a bit of cleaner on it. I'll do it quick. I usually use isopropyl, but for this, because I'm doing a video, I want to do it quickly. I'm going to use acetone, which will definitely get rid of all that gunk. Yeah, I left it pretty sharp on that cut off there. That's the trouble with this white coating on all these detectors, it's a real pain in the proverbial to deal with. Yeah, I'll even clean those up. Everything gets a bit gunky. Burning that white paint with the iron. But I'll zoom in. We'll get this up there. Don't know what, it goes too blurry on this. What if I tap it? There you go. You can see I've resoldered that through plate. We'll just see how that goes anyway. I'll turn the detector back on. Grab this. I don't think that was actually the problem. It didn't look, green enough to be completely chewed out. I'd say it was still conductive. Oops, please go back into focus. Oh, hang on. I'm probably zoomed in too far. But we'll get the plastic stick. I'll hold all this down again. I'll even try and hold the board over here a little bit. And stretch the fingers. Still sounds off there. So it may be I've got to replace those capacitors under the board, which wouldn't surprise me. So, but let's try it again. I was going to flick it into tracking. That's just me touching the cables and things. So it's in tracking. This is normal mode. That's pretty standard, actually. About that much noise in normal mode with a Kalgoorlie hot rock. I've tested this on multiple detectors. But what I'll do, I'll replace those two capacitors anyway. I'd say that won't hurt. Yeah, they've got to be good capacitors too. You can't put any very high dielectric type leaky high dissipation capacitors in those positions. They've got to be good. If you can use I'm not going to say use polypropylenes or something like that, but you could use those what are they called? They got a funny name. The silver things, the something or other sulfide capacitors, low dissipation capacitors. Anyway, you don't want you want them to hold value until the next cycle. Don't want them to drop because it just makes the detector noisy. But that's how to check on these by putting pressure on those ICs, like I was doing. All these ICs here, it's actually pushing the capacitors onto this silicon under the board, and slight pressure on the capacitors will show up faults or problems in the capacitor, either the way it's soldered onto the board or its internal structure. Just by putting a bit of pressure on those multi-layered capacitors moves the ends to the plate, and it will, especially there, it's very, very sensitive, it will sound off. So maybe I did cure the problem, because it actually is ground balancing, and I'm just probably stressing the capacitor a little bit. But what I'll actually do, I'll get a detector I know that's working perfectly well, and I'll just perform the same test by putting pressure, and hopefully either it does the same. If it does the same, I've cured it. If it's doesn't sound off, well, then there's still I better replace the capacitors, the two capacitors on that channel. So yeah, hope that helps if anyone's out there with ground balance problems. If you do have a ground balance problem that just won't go away, I've had this before. and I'll just point this out. I've had some detectors where, oh, there it goes. There's my wooden pointy stick just popped out under the bench. There has been cases of through plates and track work around here, which is broken, not connected, and I was trying to think of, for memory, what else there has been. There's various resistors here, 3. They're all the same per one. You can check those. They all should just read the same, whatever values they are. You can measure them on circuit because it's the same circuit on each channel around here. So there's no interaction with anything else. And the only other thing to really look at is the capacitors underneath. You know, I have found a lot of capacitor faults, not design faults, but the capacitors over time, for some reason, I don't know why, how, but they go leaky, they go short circuit, they do all sorts of weird things. And it's like on the SD2000s, they just suddenly would not receive. You couldn't get any target response. And it was always the same capacitor, which is on a BS170 MOSFET in the front end. It's basically used as a hold-off circuit, and there's a capacitor there which gives it some delay on the gate, and I think it's not very large value. I think it's 22 or 33 picofarads, and many of these capacitors go short circuit or they go extremely leaky, so they're no longer a capacitor. So I found that in many detectors. Also the older GPs, the polypropylene capacitors, I've had them go open circuit, and it won't ground balance either. So yeah, the capacitors on these detectors do fail from time to time. But yeah, that's a fairly easy. I should have showed what this was doing when I first put it on the bench. I was just lightly touching it like this, and it was screaming. And when I was trying to ground balance it, it would only, because I'm running a double D coil, it would only ground balance. This is interesting. In one section of the coil, if I ground balanced it on one section of coil and moved it across, it would go out of ground balance straight away. And that's a big telltale that there's something wrong in this area here. More so under the board than on top. But like I say, I don't want to go and bend up the mylar strips. You really need some sort of jig to do these. You want something that allows for holding the height on these inductor transformers, the capacitors, and also down onto the board, and keep these from getting squashed, because you put a sharp bend on these, they'll break the copper. So that's very, very common. Anyway, I'll do a bit more work on this. It should be pretty straightforward anyway now, because it actually is ground balancing. The only thing I could do, I'll put it in enhance, and this is the proof of the pudding for ground balance on a 4500, because you know these hot rocks, that's pure ironstone. Like if I got my magnets here and I just went near that, and it just stick like that. So, and it's very difficult to get off. So it's pure ironstone. So what we'll do, we'll flick it from the fixed into tracking, and I think it's repaired. I think my pushing down on that is just moving the capacitors a little bit. You know, maybe it was a solder problem there. I'll just go over it a bit, and you know, I think it's good. I better compare it with another detector just to see if that residual's the same on all of them. Anyway, hope that helps. You guys out there want to fix these things up, Catch us later.